Hi everyone, thank you for joining today's webinar on why is now the time to rethink edge orchestration. I'd like to welcome our audience. Thank you very much for joining. Before we get started, I just want to run through some logistics. So you are all in listen only mode. Should you have any questions for us throughout the session, please just drop those into the question box in the panel on the right hand side of your screen. I do encourage you all to submit questions that you have for our panel throughout the presentations. And thank you to all of those of you who have submitted questions already ahead of the session. We will do our very best to cover as many questions as possible during the live Q&A that we'll have at the end. But for those that we don't get time to address, we will provide answers offline and share that documentation round with all of you following the session. We will also be sharing the recording of today's webinar as well as the accompanying presentation slides shortly after the session finishes. So please do feel free to share that round to anyone who you feel might be interested. I also wanted to briefly mention that some of the things that we cover in the session are based off a recent research report that we've done on the topic. So as you can see, that's why is now the time to rethink edge orchestration. That's free and available to download on the Edge Hub of our website, STL Partners. We will be sharing a link round with all of you after the session as well, so I'd encourage you to have a read. So now I would like to introduce our presenters and panelists. So in today's session, firstly, there's myself, Ria Jamnadas. I am a senior consultant at STL Partners, and I will be moderating today's session. We also have my colleague, Dalia Adib. Dalia is one of our directors at STL Partners. We'll also be hearing a presentation from my colleague, Ani. Ani is a consultant at STL, and she will be presenting on what edge orchestration is and why it's needed. We'll then be hearing from Nearby Computing's David. David is co-founder and CTO, and he will be giving us a presentation on what Telco should really be looking for in an edge orchestrator. We'll then be hearing from Shankar Venkatraman from Detasad, where he's Senior Vice President. And Shankar will be giving us a real-world example of an edge orchestration solution in action from Saudi Arabia. So as I said, we'll be hearing presentations from the three of our panelists, and then at the end, we'll move on to the Q&A session. So without further ado, I would like to hand over to my colleague, Ani, who will be kicking us off with the first presentation.
Thanks, Ria. Hi, everyone. I'm Ani. I'm a consultant at STL Partners, and I've been working quite closely with the Nearby team, trying to really deep dive into edge orchestration and try to understand what it is and why it's necessary. So I'd like to share some of our findings with you today. So the latest STL Partners research predicts that the market for edge computing will reach almost $200 billion by 2025, which is exciting news for all of the players in the edge value chain. And as one would expect, the application layer, which includes revenues associated with edge orchestration, will take the lion's share of the edge computing addressable revenue in the coming decade. But even though the market is growing rapidly, it is still nascent, and there are big shifts happening in how enterprises manage their IT stacks and applications. And so we see that application architectures move from centralized models to highly distributed ones. So the big sphere on the left-hand side of this diagram represents centralized computing, which is likely to take place in a data center environment. And we can see the move towards distributed computing. This type of computing relies on a multitude of edge nodes across different types of edges. And this move is largely driven by the desire to combine the benefits of local processing and central cloud. And so these distributed environments at the edge are quite heterogeneous. For example, there are different levels of compute capacity with varying hardware resources. Also, there are multiple access technologies connecting the environment, which are not always easy to access and manage. In this context, edge orchestration becomes critical, as these differences make it more difficult to onboard applications and ensure application performance, as well as monitor and organize the resources, the networks, and the applications themselves. At the same time, we know that edge use cases running in this environment have strict performance requirements, such as low latency and high bandwidth. And so This further, makes edge orchestration critical, especially in the context of the following scenarios that I want to go through. So the first scenario is when your end device or your end user moves away from the edge node. And here the workload needs to move automatically to an edge located nearest to the end users to ensure connectivity meets application's latency requirements. The second situation that I wanted to talk about is when you have specific hardware requirements. So here, workload placement needs to be determined by whether the appropriate hardware resources are available at the edge node. So for example, the orchestrator might need to find high-performance hardware for harsh environments. The third scenario is when you have fragmentation, meaning that the application is deployed across thousands of sites. And in this case, the application should be deployed centrally across all edges and automatically adjusted to suit each edge's environment. And then the last situation, which makes it difficult to guarantee a high level of performance and makes edge orchestration essential, is when you have fluctuations in network performance. So in this scenario, the application is automatically moved deeper in the edge in areas where the network suffers high latency. So regional edge or cloud can be used in areas with better network performance. So the need for edge orchestration is clear, we've established that, but it's also useful to sort of illustrate the role of an edge orchestrator on an example. So to illustrate that, we wanted to give you the example of cloud gaming. So the user playing the game can choose the device that they want to use to play the game, and then as they move from location to location, the edge orchestrator makes sure that the workloads are moving depending on the end user's location. So for example, as the gamer plays the game at home and then she walks to school or even rides in the bus, the orchestrator quietly moves the workloads around. But one thing to keep in mind is that the orchestrator needs to be aware of the underlying hardware resources. For example, GPUs might be required for certain workloads. This means that when moving the workloads between servers, the orchestrator doesn't just move the workload to any node available. It needs to ensure that the server meets the underlying hardware requirements. And one more thing to note, so as the movement of the workload is happening, we know that gamers care about latency or ping time. So it means that the edge orchestration needs to happen quite quickly as well. So this is an example use case. And apart from helping to sort of deploy these use cases, edge orchestration also helps operators with enabling new solutions and new services. And telcos are already exploring different business models for these new solutions. We will be looking at three models. So the first one is called NaaS, or Network as a Service. And in this model, telcos have the opportunity to provide end-to-end networking solutions across on-prem and network edge. And the focus here is really on the network and optimizing connectivity between edges. And some examples of this model, or operators pursuing this model, would be Vodafone with the Make IoT SIM, or AT&T with its network and Make offerings. The second model that we look into is called IaaS or PaaS, so Infrastructure as a Service or Platform as a Service. And in this scenario, operators offer platforms to enable enterprises to manage workloads, applications, and connectivity, as well as extend capabilities across different clouds and different edges. And example operators that are deploying this model or pursuing this model would be, for example, Cox Communication with its Cox Edge platform, or Verizon with the DNS application edge. And then last but not least, the third model is called end-to-end solutions. And as the name suggests, here operators offer end-to-end solutions for enterprises. So in this case, the telco takes care of bringing all of the pieces of the puzzle together. including the infrastructure, networking, as well as software platforms and applications and managed services. And examples here would be from KDDI's OVision Studio for XR and Verizon's environment for AR/VR use cases. And it's important to note that depending on the model that the operator is pursuing, there will be different requirements for edge orchestration. So, for example, in a NAS model, so the first model, the orchestrator might need to automatically instantiate network services, such as network slicing or network-based APIs, or it might need to provide information for other platforms or applications to ensure that they are network aware. And then another orchestration capability for this model would be allowing the telco or the SI or even the vendor operating the network to discover edge nodes and deploy network functions on the infrastructure quickly. And then moving to the second model, the orchestrator here in this scenario would need to allow developers or enterprises to discover edge nodes and then also enable them to configure network and infrastructure requirements. At the same time, the orchestrator would also need to automatically move workloads to different edges to ensure the application's KPIs and SLAs are met. And then when we look at the third and last model here, end-to-end solutions, the edge orchestrator would need to ensure that the underlying infrastructure and network meet applications KPIs. It would also be responsible for providing customers with an uninterrupted service that meet SLAs. The orchestrator or the orchestration requirement would also include optimizing application performance by automatically configuring infrastructure, networking, and the application, and all of this while reducing costs. And finally, in this last model, the edge orchestration requirement would also include maintaining application performance regardless of hardware or network type. So we can see clearly that the need for dedicated edge orchestration really grows as you move from model 1 to model 2 and then finally to model 3. This being said, telcos are, as I said, are exploring these different models, and they are trying to figure out the associated edge requirements, but naturally, a lot of telcos still have questions, and they perceive the edge orchestration ecosystem as complex, and rightfully so. There are many different companies that are offering different capabilities, and sometimes it's really hard to make sense of the value chain and of the vendors and partners that the telco should be working with. And so some questions that might spring to mind would be around the different types of edge orchestrators out there, or maybe even around the question of justifying yet another investment in an orchestrator. And this being said, these questions are valid, and telcos are starting to think about them in the context of their evolving edge strategies. So telcos are trying to now understand how they can manage their distributed systems as they invest in edge computing, or maybe they're trying to understand how they can manage everything in a more automated way. And so to really sort of to make sense of this situation and the opportunities available to them, operators need to understand the capabilities and requirements for edge orchestration that are specific to their unique needs and ambitions. And so this is it from me, and I think my colleague David from Nearby will be talking about some of the unique capabilities that edge orchestrators enable. So I'll hand it over to David now.
Okay, so thank you, Annie. Thank you everyone for attending. So let me explain a little bit more about edge orchestration and what we do from Nearby Computing. So let me see if I can transition slides. I think I'm not able to do that. So if we can go to next slide. Okay, so let me explain first who we are. Nearby Computing is a company based in Barcelona, in Spain. Our main activity is the development of an edge orchestration platform that is called NearbyOne. I'll be explaining first today a little bit the main concepts and differentiations between what an edge orchestration is, or what we think an edge orchestrator is, and what does it differentiate it from traditional network orchestration solutions. But before that, just to mention a few words on the main concept of edge management. So you have here a list of some of our relevant customers, and we have today here Shankar from Dataset that is will explain a little bit more about the edge market in Saudi Arabia and how we are building together a cloud edge solution in the kingdom. So sorry, too fast now. So let me start by explaining first what is the main differentiators, or what are the main differences when you talk about orchestration, when you transition from traditional late data center orchestration, network orchestration as traditionally done, and when you go into the edge. Okay, I'll be splitting that into three main concepts. Let me start by differentiating the two of them. So there are several aspects that when you put all of them together in the edge, they make orchestration much more challenging than what you usually get at the data center. That is not easy, but still is easier than going to the edge. So I try to split here into some of the most relevant differences we observe when we approach edge computing projects in terms of the different elements in terms of management that you need to deal with. So first of them is latencies. When you think about the infrastructure, and I'm not talking end user latency, I'm just talking about latencies within the infrastructure. It's completely different to think that you are in a data center when in a scenario in which the latency end-to-end between every single pair of nodes is pretty much roughly equivalent. So most of the data center has same latencies. Sometimes you split that into different availability zones, but in general, the latency is a high-speed fabric, so quite homogeneous. When you go to the edge, and next slide, I will explain a bit more on what I mean by the edge. This becomes highly heterogeneous. Different locations, different tiers of the network, quite different locations. Second difference is equipment diversity. Usually in the data center, most of the hardware is homogeneous. The vendors, cloud providers and data center providers, they try to get same SKUs going all over the place, as minimum configurations as possible, just because that simplifies the management. When you try to go to the edge in the same way, there's no way in which you can apply that same pattern. Every single tier of the network uses different type of equipment, different type of facilities, different type of physical format, factor format. So it's quite challenging in that sense. One more aspect: location and transport networks. In data centers, usually the biggest jump you get between different locations is availability zones. Most roughly, that's the main difference. And the transport network, or the fabric that you use to interconnect all those components, is in all cases, this is owned by the owner of the data center. When you go to the edge, location is massively distributed, and in many cases you have segments of the network that is not owned by the operator itself or by the the edge manager. Why? Because there are some transports that may belong to the customer itself. So you have an interplay between the service provider and the customer itself. So there are points at which different tiers of the network where over-the-top approaches is the only way to go, and that's challenging in some way. Resource availability. In the data center, it's virtually unlimited. That's the magic of the cloud concept, right? It's you know that you have limits, but you try to make them not obvious when you deploy things. You don't expect to be limited by the number of VMs or containers that you can deploy. When you go to the edge and different tiers of the edge, that's not true anymore. It's geolocated, it's limited, it's fragmented. When I say geolocated, is some workloads need to sit exactly in one specific site. So in the cloud, usually you never choose I want to run in this specific server of the data center. You get a fabric of data center, compute resources in the edge. Quite often, there are tiers of the network that require precise location, and that means that resources are scarce. They are limited, and they are heavily fragmented because of different sites and locations. Access technology. When you talk about data center and mainly NFV management, network management. You manage BNFs or you manage telco services by groups of access technologies. So if you are talking about the RAN, your 5G RAN, you are talking about set of BNFs that are implementing that. When you go to the edge, there's always a mix of technologies. Access is multi-access by definition. Many of the use cases we work with, they require Wi-Fi access, wired access through laptops, etc., and also LTE or 5G connectivity for some of the devices and UEs. So it's completely mixed, and that means that the interplay between all of them is much more challenging. Cost of technicians and access to the field. In the data center, that's something that is quite immediate. You have some staff on site, you have spare units, you can replace them, you can send them any minute of the day, and that's a very quick move. When you go to the edge, it's often the case that it takes hours to move someone there. We are in a project, I will be mentioning that in the next slide, about rural site management, in which the closest guy is 2 hours away driving from the location of the site. So anything that happens is painful in the sense of waiting time, cost of moving people there, etc. So over-the-top management, as much automation as possible at all layers is something that is quite critical. And last but not least, in terms of orchestrated workloads, data centers are mainly man-oriented, DNF management, very traditionally oriented to that. When you go to the edge, adoption of CN container native solutions is much rapid it's much faster compared to in the data center, and across the multiple tiers we see that containers are possibly the way to go. Most people is going in that direction, and that means that in terms of management there are operators, there are custom resources, there are many things that have nothing to do with the traditional notion of a virtual machine. So that means that the target of operation for data center oriented workloads and applications and edge environments is completely different. And you have to remember that all of this is spread across different tiers of the network. So what I like to emphasize in this slide is what I call the real edge. Okay, there's a lot of discussion about edge cloud, telco edge, etc. Several use cases always appear: distributed CDN, gaming, as we were discussing in the previous deck, IoT analytics, etc. Those are the traditional edge cloud data center or edge data center oriented, cloud data center oriented edge use cases. But this is not the ones that are driving most of the use cases we are seeing. So we have included here on the right side some examples of real projects we are involved into about different types of deployments that span from the data center to the edge. And there are many specificities of these use cases that are challenging, and this is what I like to call the real edge, because this is the reality. For instance, if you revisit now the topics that I was discussing in the previous slide about data center characteristics and edge characteristics, just taking this slide, the top right use case about the embarked node in a firefighter's track. So this is a project with the city of Barcelona and the firefighters of the city on mission critical services, that it involved deploying an embedded edge node inside of this track, backhauling through a satellite network, and in this case provided by local constellation here in Europe. And in this context, you have to create a 5G zone that provides some critical services to the firefighters that are moving around and some drones that are flying. So this is a completely different approach to a data center. This is an embarked node that you need to run in very tough conditions inside of a mission critical environment, embedded or embarked inside of a node. Or also, if you look at the outdoor sites that you can see on the two cabinets that you have here, street cabinets in the city of Barcelona and in other locations. Actually, this one is not in Barcelona. They are quite constrained in terms of resources. They have form factors that are limited. They are massively distributed, thousands of locations of this type. If you look at the left side, outdoor V2X sites for tough conditions in hot weathers, liquid cooled, so liquid immersion of the servers themselves. There's a lot of infra management here. This is not approach to, not similar to data centers. So real use cases require one final step, what I like to call the last mile, not in terms of connectivity, but in terms of management and deployment, that is quite complex. In the utilities sector, the rural edge use case also that I was mentioning before, satellite backhauling, solar power, providing 5G connectivity to one region in which there's no coverage for smart farming, for instance. These are real use cases. This is the reality. This is what you find when you try to go close the gap with the edge. So how do you address this type of challenges? So we have different approaches for this. So we have automated policies in the system. So I will discuss that in more detail. But the main idea here is let the system be the one that, based on SLAs, telemetry, measured latencies on the system, make automatic decisions on where to place the different services. That's a fundamental factor here. Letting the system not work in manual deployment. I cannot just take one service and say this runs in this server. I need to provide to the system a set of policies that say, what are my preferences? Can I just render dynamically the configurations of an application to make sure that the cameras are self-organized and the video analytics application is consuming the video feeds from the cameras for which this node is the closest one? So that's a scenario. It's a real scenario, a real deployment for the V2X scenario I was mentioning before. So we need to let the system be auto-organized. And this is something that when you consider massively distributed infrastructures, that's challenging. You need to have ZTP and ZTP capabilities over the top management of the infrastructure, etc., etc. A lot of characteristics that make the system autonomous in a sense that it can be self-managed and can let the system be operated based and driven by policies, not by manual decisions. And the last item in this list is applications first. That's something that I always emphasize, because when we talk about edge, quite a few people think that everything is about connectivity. We talk about edge, and everybody knows about these use cases that you can see on TV and news about surgery through 5G networks or very extremely low latency, connectivity. That's true. Those are things that people is talking about. The real demand for use cases today sometimes have to do only with privacy. So keeping all data local, having my own 5G network, or having my edge site with my connectivity services that no one else is sharing. So that's something that many people are requesting. And in that type of scenarios, connectivity is a commodity in some way. It's not the main player. All these deployments go driven by the applications and the applications that are needed. So the main idea is to have a single pane of glass that can let you give you access virtually to all applications, telco functions, infrastructure, to reduce the cost of the management of the infrastructure and accelerate and generate new source of revenue for the edge management companies, so that they can create new opportunities. This is a green market, a green field still in many senses. One more comment here. We are talking about edge orchestration. We are not saying that we are replacing any of the other players that are in this ecosystem, okay? And the edge is all about a mix of players. We don't have any single edge deployment in which there's no cloud player, okay? For different aspects. For hyperscalers are providing quite good services that people is consuming. We have many of these IoT platforms, so they are the ones that customers choose in industrial environments, for instance, to do the data aggregation of the edge tier. All of these players are needed. Telcos, hyperscalers, IoT platforms, edge cloud platforms. We are not saying they are not part of the ecosystem. What we need is the gluing piece. Usually when I talk about with customers and they ask me about these players, they believe some things that are not really true. For instance, hyperscalers, they have a huge marketplace. Okay, they have a marketplace, but MySQL or Prometheus are not a use case. This is just an application. No real end user, no real customer is consuming them standalone. They need to glue them and create a service chain of components and get end-to-end management. So it goes beyond the marketplace of applications. Telcos, they tend to think that everything is about the connectivity. And we have many use cases in which connectivity is not the challenge. There's no 5G, no MEC, no ETSI, no GSMA involved at all. There are other types of technologies, wired technologies, industrial protocols, Modbus, etc., that have nothing to do with the connectivity itself. But those are part of the use cases. IoT platforms. IoT is not ending at the edge. You can get data aggregation, you can get intelligence on the edge, but most customers demand IoT Hub, Azure, AWS Greengrass, this type of cloud aggregation platforms. So the edge is not just about the edge, it's about the edge and all the other tiers all the way up to the cloud. And last but not least, edge cloud platforms. So there is a trend to think that the edge is only enabled by applications that are edge specific. So getting these APIs for mobility, for that type of telco-oriented services, we don't know any ISVs that are ready to do that migration. Applications are not designed for a specific access technology or deployment type. They are designed to be agnostic of the access technology and the location of the deployment. So what we provide from an edge orchestration point of view here is gluing all these components, is creating an ecosystem that based on this manifest and non-coding can be associated actual end-to-end deployments with real policies that can enable a lot of features that facilitate the deployment on the edge. So that's what we offer from Nearby Computing. Our product is NearbyOne. This is a end-to-end management solution, what we call a one-stop shop for edge operations. This is operating across all tiers of the network, so from the IoT devices all the way up to the cloud, and we are completely vendor agnostic, managing infrastructure, BNF and CNF, and the application marketplace. So that creates a single pane of glass that the consumers can use to just click one button and get one edge environment created, interplaying with the other players of the equation that I was mentioning before. So how does it look end-to-end in the telco sector? We have different deployments in which this is just two examples. So I cannot get into the detail of that, but just for everyone's reference, as the slides are going to be made available, this is just examples of how domain orchestration for edge computing can be integrated in the global picture. So for an end-to-end orchestrator that is talking to the domain-specific orchestration for transport, for RAN, for the core itself, enabling the edge is just a matter of enabling a set of functionalities very specific for the edge. That's not meaning that we are replacing end-to-end service orchestration. That just means that we are competing in that sense. This is just one additional piece that from the end-to-end point of view is needed. And that does not apply only to cellular networks. So we have projects in which this is SD-WAN enabled for franchises through service providers. That's exactly the same ecosystem. This is just replacing the pieces that you have behind the end-to-end service orchestration, but still you have some requirements that are very much edge specific. Okay. So my conclusion here is no, domain orchestration solutions are not competing. We are not trying to kill each other. We are not trying to replace each other. So in the end, service providers are usually, let's say, the best friends of both network orchestration solutions and edge orchestration solutions that is gluing both of them to be able to deploy edge services in just a few clicks. So that's it on my side. I will hand over now to Shankar, that from Datasat will explain a little bit more the business side of how these type of solutions are being deployed as we are speaking in the kingdom and the opportunities in the market that they are foreseeing. Shankar?
Thank you, David. Hello, everyone. My name is Shankar. I'm the Senior Vice President at a company called Datasat. It's a 40-year-old company established in Saudi Arabia. So most of what David, Annie, they were talking about, particularly on the edge orchestration and the importance of edge computing, I just want to stress upon how edge computing is playing a significant role in the Kingdom of Saudi Arabia. But before we get into the details of how edge computing is really making a foray in the kingdom, I just wanted to draw your attention on some very key statistics. Saudi Arabia, as everybody would know, it's a very large country. It's a country of almost about a little over 2 million square kilometers with a GDP of about $800 billion. This is as of last year, 2021. And it has a very small population of about 35 million people, right? So you can imagine how widespread the kingdom is. It's highly fragmented. You'll only see pockets of population across the kingdom because of the terrain. Now, about 3 years back, the kingdom actually embarked on a very ambitious program. They wanted to transform the entire kingdom in various parameters, right? So the three pillars were how can the economy thrive, how can the society become a lot more vibrant, and how can the nation as itself become ambitious. So there were about 28 goals that were defined by the kingdom, and I'm just calling out some very important goals which will be relevant for the topic today. So first and foremost, one of the most important goal was to increase the non-oil GDP from 16% to 50%. What it means is today the GDP of the kingdom is about $800 billion. Now, in about 8 years, it needs to be 50%, which is almost with a 2.5% growth or average growth every year. Your non-oil revenue alone should touch anywhere between 550 to 600 billion dollars, right? That's a big number. Now, as of today, the number of the non-oil revenue is close to about $100 billion. So they have a significant gap that needs to be bridged. One of the things that the kingdom has done is to open up a lot of new avenues for revenue generation. And one big area is mining. Mining is an industry which is going to be the second pillar. They call it as a second oil generation industry sector. And mining is something which is really picking up a lot of steam in the kingdom, apart from transportation, logistics, and as well as manufacturing. In terms of logistics, the aim or the objective is to elevate the kingdom from a 49th position to a 25th position. What it means is eventually the kingdom would like to become the hub when it comes to the transportation and logistics in this part of the world. So to that extent, the kingdom is actually building something called as a floating industrial city called as Oxygen. You can actually refer in any of the public sites. It's called as Oxygen, and it's a floating industrial zone. So this will enable freight movement in a very short span of time with no bottlenecks. And this is the intent is the whole economy is actually going to boom going forward. And one other aspect that the kingdom is actually aiming towards is they want at least 3 cities in the kingdom to be on the top 100 smart cities list, right? And all of us know if you want to become a smart city, there are some fundamental parameters, be it the quality of air, the transportation facilities, the medical facilities, the speed with which a medical facility can be rendered to the citizens, so on and so forth, right? So there is a lot of activity happening towards making 3 cities very smart, at least in the top 100 list. Now, if anyone looks at the parameters or the objectives that I have laid out here, the most important thing that comes to the mind is unless there is an enormous transition in the way technology is adopted in the kingdom, well, this is not going to be that easy a task, right? So technology is going to become a critical influencing factor for achieving some of the parameters that the kingdom has mentioned. Now, one of the most important thing in the kingdom is the lack of what I call it as a cloud proliferation, right? And most of you would know that the compute power of a state or a country is determined by the megawatt per million people, right? How much megawatt is being consumed by a million people actually determines what is the compute power of the state. To give you an example, the current compute power in the kingdom is about 1.71 megawatts per million people, which is way too small compared to maybe a Dubai, which is about 20 megawatts, or maybe a Europe, which is 155 megawatts per million people. Now, what it means is that there is a concentration of compute power very close to people, so that a lot of activity can happen if where the action is happening. So there is a scope. There's a significant scope in the kingdom for for the increase of capacity of basically the increase of compute power, and very interestingly, if you look at it, how even the classical data centers are distributed in the kingdom. Close to 75% of the classical data centers are kind of concentrated in Riyadh, which is the capital of the kingdom, and about 10% of the data centers are kind of in the eastern zone. The rest of it are sporadically distributed. Now, this also very clearly shows that if the kingdom has to kind of realize some of the visions that I was talking about in the previous slides, then it's very imminent that the action happens very close to, or maybe the compute or the processing happens very close to where the action is. So there are a lot of areas where the edge computing has become little prominent. One, in the healthcare sector, because of the pandemic, what has happened is the number of calls that the patients make into a hospital has gone up significantly. As of last year, it was about 161 million calls that the patients have made to all the hospitals, which is very overwhelming. And it is almost like about 150 to 160% more than in the previous year. So with the limited infrastructure, it is going to be difficult to really manage all the patients walking in. So telemedicine and remote patient monitoring is actually becoming the most important aspect where edge compute is playing a role, right? And there are universities which is actually working on making sure this the concept of edge compute, along with the applications, relevant patient monitoring applications, and good connectivity is being implemented. The best part in the kingdom is 5G is ubiquitous in the kingdom. Almost 60 cities in the kingdom has 5G capability, and the speed, I would say the download speed is almost at about, on an average, it's about 300 Mbps. The highest being about 390 Mbps per second, 390 Mbps, and the low anywhere between 260 to 270 Mbps. But the message is you have 5G, you have very potential for bringing a compute power very close to where the action is, and companies like Nearby, with who we work with, are able to provide the applications which are relevant to bring in the edge orchestration, right? So this is what we are seeing in the kingdom. There's a huge transformation or a paradigm shift in the way compute or the data is being computed in the kingdom. And I just want to talk a little more about, of course, this is the typical edge architecture. I don't want to spend too much time out here because it's very, very simple, where you have an edge device, and the edge device, instead of sending data into a central data center, the actual processing happens where the sensors are, where the action is. So I will, maybe to make it a lot more clearer, I will just stress upon a case study which we feel is very relevant for the topic that we are discussing today. And this is the mining case study in the kingdom. So as I was talking in the beginning, mining is the second largest revenue generating industry. And as early as maybe about 2 months back, the kingdom has identified about 27 million tons of minerals south of Riyadh, and excavation has already started. So what in mines, there are some typical challenges because you really don't know what happens below the ground. There's a lot of uncertainties happening below the ground. So there are about 2 or 3 big challenges that are typically faced by the miners. First and foremost, the quality of the ore, what we call as ore tracking. So as and when excavation happens, there has to be a continuous feedback in terms of the quality of the ore, the characteristics of the ore, based on which the subsequent process, including milling and crushing, has to be more optimized. If you really do not know what kind of materials are being excavated or the characteristics of the material, then the miners spend a lot of energy and cost in the subsequent process. So the edge compute with a lot of artificial intelligence built into it is able to literally determine the quality of the ore as and when it is excavated, because of which all the following processes or the sub-processes are highly optimized. That is point number 1. That's the biggest challenge. The second challenge is what we call as the optimization of vehicle movement. So one is the activity happening below the ground. The other one is the activity happening on the ground. And these are machines which are huge. It can be the crushers, the ball millers, the earth moving equipments. They are so huge. And the movement of these have to be highly synchronized depending on the speed with which minerals or ores are being excavated. Any free movement or any idle time of these equipments actually causes a lot of delay and an enormous amount of cost. So one thing where the edge computing has really helped us is all these devices and the parameters of these devices are now centrally connected through the edge controller. Based on the output of the excavation or the speed with which minerals are being excavated, we are able to now optimize the movement of these vehicles, thus reducing, most importantly, the carbon emission. So one of the biggest things that the kingdom is talking about is smart mining, which means not much of power or diesel has to be actually burnt for managing these large machines. The third important is the efficiency of these diesel engines itself. Now, the mines, by the virtue of the locations, right, they are very remotely located. You're not going to get ready-made power which can be drawn from any cable or overhead cable. So all these machines are typically run by what we call as a farm of diesel generators, right? A grid of diesel generators, and these are huge machines. And these diesel generators, it takes time to even crank up and get into full speed. And we have to make sure that only the optimal number of diesel generators are switched on, so that when these heavy machines are coming into the grid, then obviously you need to make sure that you have enough power to run these heavy machineries. Now, one of the biggest challenge in the past was there was no control in terms of how these diesel machines are being synchronized. But with the edge controllers, what we were able to do is, once again, using an artificial intelligence, we were able to literally, calculate the feed coming in from the ground and the need of all this heavy machineries. And hence, we were able to literally calculate the peak when these heavy machineries are going to be put to the grid, and based on which only the most optimal diesel generators were actually switched on. Now, while all this is happening, it is just not only the edge which was into action. While the decisions were being taken in the edge and appropriate actions were being taken in the edge, a lot of data from the edge was still being sent into the central data center. One classic example is the AI modeling, right? When you are actually writing an algorithm for an AI/ML, you got to train the algorithm with a large amount of data. Only then the algorithm or the model can be ingested into the edge, right? So for training the algorithm on a large amount of data, it still needs to be done in a central data center where you have access to voluminous of data. And then once that algorithm is trained, then you take the data, or you take the algorithm and ingest it into the edge. And that's exactly what we have been doing. Right. So this is the I just wanted to give a overview of what is happening in the kingdom, and most importantly the applicability of edge computing in the kingdom in some of the use cases, particularly in mine. So with this, I will hand it over to Annie. Annie, you can take over, and it will be available for questions.
Great. Thank you very much, Shankar, and thank you to all of our presenters. We have got a little bit of time for the Q&A session, but before we dive in, I wanted to get some thoughts from you, the audience, on the topic of edge orchestration. And in a second, you'll see a poll flashing up on your screens. So what we want to know from you guys today is what you see as the biggest challenge with edge orchestration. So is it that you foresee challenges in making the business case and being able to justify investment and having a new system, perhaps even justifying it with other internal stakeholders within your organization? Is it that the ecosystem is just too confusing and complex, and you think that there perhaps isn't enough clarity around who's actually providing what? Or is it that you feel you just haven't been very clear on what the real benefits of an edge orchestrator will actually bring? Or finally, is it that you simply aren't seeing demand for the types of edge use cases that will require an edge orchestrator in the future? So you guys would have about a minute just to vote. Great. Okay, so you now should be able to see the results on your screen, and you can see there are two that are pretty much tied for the most popular answers, which is, being able to justify investment in a new platform and confusion around the edge orchestration vendor ecosystem. And actually, so when we were producing the report that I mentioned at the beginning, we did speak to a number of different telecoms operators to, understand how they're thinking about edge orchestration. And it's, these results are very unsurprising. We even had one telco mention that, they put out RFIs, RFPs, and there just wasn't enough clarity on exactly who was providing what. So I will now just sort of throw that back to our panel. I think we can sort of close down the presentation now, and maybe we could start with you, David. And I mean, are the results of the poll surprising to you, or is it something that you kind of expected to hear? And any kind of comments on that?
No, I think it makes sense. This is something somehow expected. I think the first most popular opinion about cost is something that makes sense, and we go through that discussion quite often. In general, you have to put on one side of the scale, say the cost of introducing one new piece of software, but that's also generating new sources of revenue, new revenue streams into companies, new opportunities that were not considered before. And also the other thing is when you show real life to customers how something that usually takes 2 or 3 field technicians, hours of work, field work, etc., and in a few clicks they can see that happening in 2 or 3 minutes. They quickly realize how there are other ways in which costs can be reduced on the long term on the edge. But absolutely fine.
Yeah.
But I saw.
Great. And we have had a lot of questions come through, but I'll just pick a few where I'm seeing a few that are sort of along a similar vein. So one may be for you, Shankar, which we had, I think, sort of when the presentations were going on, which is, what are customers, including early adopters of Edge, saying about the importance that they place on Edge orchestration?
Yeah, so I think many of them actually, they need the processing to be happening very quickly, because some of them are very mission critical, be it from a healthcare point of view or even from a retail point of view. So they expect the actions to happen really very quickly. So from their point of view, of course, in the past that was not a possibility because of the latency issue and the connectivity issue. Now with 5G, extremely prevalent in the kingdom, and kind of speeds and latency that is being promised, now most of the requirements of a healthcare industry and a retail industry can now be realized using the edge compute, right? So in my point of view, I think it is just a beginning. It is just a starting point. You're going to see an explosion of edge adoption very quickly.
Great. And there's another question. I think, Dalia and David, it would be great to get both of your perspectives on this one. So how should telecoms operators partner with orchestration and integration software vendors to deliver edge orchestration for customers? Maybe Dalia, you could sort of go first, and then David, we could get your thoughts as well.
Yeah, sure. I mean, I think Annie touched on this in her presentation, that it depends a little bit on the business model that the telco chooses to pursue, and therefore then what the role of the orchestration vendor is, and how that changes over time. And what I mean by that is, if you're going to be focused on mainly providing networking as a service to enable edge computing, then the level of orchestration you'll need is, more on the networks level. The other, I guess, factor to consider as well is at what level or what type of edge you want to be orchestrating, because and all three presentations talked about the different types of edge computing. You have on-premise edge and network edge, and so that's one aspect. If you're looking at your own network, then that's also one level of complexity. If you as a solution provider want to be kind of agnostic to different types of networks, so being able to support, say, Wi-Fi, mobile networks, even fixed networks, and plus different types of edges, the level of orchestration that's needed goes up exponentially, and the requirements you have are much more difficult. So that changes again, like the dynamics between the orchestration platform and the telco. And then I think that the last point that we've heard around partnerships is looking at the commercial model, and we've kind of heard a mixed view, and I'm sure David is closer to this and he'll have different opinions, but in terms of the business model, so some telecoms operators are moving towards, maybe more of an OPEX kind of base model or a revenue share model, where they would like to reduce the upfront risk and work with the kind of orchestration platform on a success-based model. So as they go to market together and customers adopt, then sharing that risk. Others are more focused on a traditional model, and that's because partly it might be the perception of orchestration, and there's a kind of like traditional license model that's still prevalent in network orchestration that telecoms operators prefer to continue in edge orchestration. And also, it's kind of to do with budget cycles and when budget is released and that sort of thing. So those are some of the things, like the factors that we're seeing around that question.
Great. And David,
Yes.
did you have any thoughts as well?
No, complementary to what Daria was saying, I'm trying to be brutally honest here. I think telcos are in front of a critical decision, is how much they want to get their hands dirty with edge computing. It happened in the past with over-the-top content providers, that they flow over telco providers and they didn't realize connectivity became a commodity for them. So I think we are in a very similar situation, and I'm talking about telcos at this point. They have to decide how far into the customer's environment they want to go. System integrators have a fundamental role here. When you go to industry, when you go to this type of end customers, the SIs are the ones that know and understand the context, and at the same time, the telcos have a very valuable asset that is frequencies and network expertise. So you have to glue all these things together, but this is depending on the appetite that they have. I think Dataset and what Shankar explained is a very good example of that. Is seeing how an infrastructure company like Dataset, cloud provider like Dataset is jumping into that. He was not talking about data centers. He was not talking about networks. He was talking about mining and use cases. So that means you get your hands dirty, you go to customers, and you decide if you want to jump into private space or for your customers, if you want to even deliver some managed services. That's their call, but I think system integrators are the fundamental piece that is making that all the others are surrounding around that.
Great, and we only have a couple of minutes left, so try and squeeze in one or two more questions. We had one that says, so is a common end-to-end orchestrator the best approach, or is a better approach, having a separate orchestrator for each function? So, the RAN, the core, etc. And that being controlled end to end. So I don't know, Dalia, would you be able to take that one?
I think it's similar to the last question in that it's dependent on the strategy that the telecoms operator has chosen to go ahead with. But I think realistically, they're not going to be replacing the say the Mano or some of these existing network orchestration platforms anytime soon. With an all-encompassing orchestration platform, and that has a very specific purpose, and there's skills and capabilities required to deliver that. And so in general, it will be, I think, the second option that the person asked the question identified, which is having some an overlay that can orchestrate above existing orchestration platforms and be able to monitor and provide that visibility and manage workloads and other resources across the different existing platforms.
Great, okay. Unfortunately, we have come to the end of the hour. I'm aware that we have got a lot of questions that have been submitted, so thank you so much to all of our audience. As I said at the beginning, we will do our very best to answer them offline, and following this session, we will be sharing the recording from today, the slides from our presenters, and the answers to the Q&A session as well with all of you. So all that's left for me to do is say thank you to our audience for joining, and thank you to all of our presenters and panelists as well. Have a good day.
Thank you all.
Thanks, everyone.
Thank you.
Everyone.